Good morning, all. Now, myself, Dr. Praveen, Associate Professor, School of Computer Science and Artificial Intelligence, our university. Now, today, I'm going to explain pointers with to 1D array and two-dimensional array. Okay, pointers with one-dimensional array and two-dimensional array. In the last video, I explained one-dimensional array with a small example. Right now, today, I want to explain two-dimensional array with the suitable examples with pointers, right? Now, yeah, I think everyone knows the definition of pointer. Pointer is a variable which stores the address of another variable. Okay, when you are declare the variable, you specify the data type, space, variable name. If you have more than one variable, variable 1, variable 2, swan variable m, right? As well as if you have more than one pointer, now pointer 1, it is preceded with the star symbol, asterisk, data type, either integer, float, character, right? Data type is primary data type, space, star, asterisk, variable 1, comma, variable 2, swan variable m. Yeah. Now, pointer 2, for example, sometimes we have to take the pointers to string also. Now, C language supports. In last video, I explained integer. How can we declare the integer pointer? How can we read the integer pointer variable, right? How can you read the character integer array? Simple. Here we take the integer data type a of 10, comma, or ptr. Observe here. A of 10, comma, star ptr. Now, pointer is a variable. Okay, when we take the variable ptr equal to ampersand a of 0 or or ptr equal to a. A is a base data base address. The base address is assigned to the pointer variable. So now ampersand of 0 means the first address, base address is assigned to the pointer. Either you are use the first notation or second notation. As well as what do you mean by int a of 10? Now which allows the integers, 10 integers, right? 10 numeric values. Sometimes we have to take the character array. Character array nothing but, for example, you want to read your name, or you want to say some hello to your friend, right? Then we can declare a character array. Character, character str of 10, which allow the 10 characters, hello semicolon. Now we declare the pointer array also. Now why we are use the pointer array? Pointer is a variable which stores the address of the another variable. So we declare the pointer variable character star str1, star str1. For example, this is the str. Now this is the like what is the address here? Some example 1000, 1001, 1002, 1003, 1004, 1005, 1005. The base address is the 1000. So now this base address is assigned to the str1. str1 equal to base address. It means now here 1000 is assigned to the str1. Now, printf percentages for the string character star str1, star str1. Now str equal to str. We should take the str equal to hello, and str base address is 1000. So star of 1000. What is the character we have? Star of 1000 eight, and we should increase the values and 1001 because the array is a collection of similar data items. These data items are reside sequentially in your memory. So it will return the HELLO. Last character is the null character. Always the string is terminated with the null character. Okay, now this is the basic pointer to string array. Pointer to string array. Already last video we completed basic pointer to arrays. Now these are all over. Now I want to take one program also. This is coming. This is already, these all concepts. Yeah, arithmetic is already completed. Now coming to the pointer to. So now I want to take the program for the int star p a of 10. Now same way you write the program for string. How can we write? How can we write? Tell me. Now what is the data type here? Character star p. Instead of integer, you should take the character star p. Now a of 10. A of 10. Right? A of 10. Now, P equal to A. Observe here. P equal to A means the base address is assigned to the character. And next, no need of number of characters. We should read the string by using the str. Right? How can we read? Now scanf, percentage yes, right? Percentage yes, A, or A of something. Use the for loop, right? And how can we print R P? That's it. Printf percentage yes, comma, star P. Star P indicates the character from the base address 1, base address 2, base address. That is about the program. Now, up here, this is the program for a sum and average of array elements using with the pointers. Now, how can we read the pointer word? Simple. PTR P plus I. P plus I indicates P equal to A of 0. Right? I equal to 1. So you know the scale factor. Last video, I explained scale factor. Scale factor I value equal to 0. So 0 into size of the data type. Now here data type size is the 4. P equal to 400. 4000. 4000 plus I value equal to 0. 0 into 4. 0. So the address is the 4000. When we enter the first value is reside in the 4000. And I value is updated. I equal to 1. Say 1 less than n. Again condition is satisfied. So scan a percentage t p plus I. What do you mean by p plus I? P is not changed. Your observer. P is same value. That is the p equal to 4000. V is zero. Now I value. What do you mean I value? I is updated. I equal to now 1. 1 into size of data type. 1 into size of data type. 1 into 4. 4000 plus 4. 4004. The next element is reside in the 4004. Continue until condition fail. Until condition fail. And now we have to print find the sum of the elements and as well as average of the elements. For I equal to 0, I less than and I plus plus. Okay, sum equal to sum plus star p. Now sum equal to star p means you observe here. Here we have take the base address star of this address, star of 4,000, star of 4,000. Okay, now star of 4,000, what is the value? What is the value? Now, for example, 5. We assume 5. Sum equal to 0. 0 plus 5, 1. Now, p value is updated. Now, observe it. P value is, this is also integer. So, p equal to p plus 1. P equal to p plus 1. P plus 1 means, p plus 1 means that is the next address. Next address is the 4004. Next address is 4004. Now, star 4004. Sum equal to now 5 plus star 4004. Suppose 8. We are enter 8 already. Now 13. 8, 13. So again p plus plus. Now p equal to p plus 1. Find sum. After this statement, next we go to the average. We find the average. Now here I want to use the explicit typecasting. Explicit typecasting. Okay, without this, you print the average value. Average value without precision, direct value will be returned. So that's why we need the explicit typecasting. We can print the accurate value, right? Sum value and average value. This is the program for the find sum and average of single dimensional arrays. And two-dimensional arrays, okay, now two-dimensional array, we will explain, I will explain, right? Good evening all. Now, today we will discussing problem solving using in the concept is the pointers 2D arrays. Okay, two-dimensional arrays. In last video, I explained one-dimensional arrays with some example programs. Now, in this class, I want to explain the two-dimensional arrays, how the two-dimensional arrays are represented using with the pointers, and some programs we will discuss like matrix programs. Okay, because in matrices is mainly the 2D arrays, main objective is the matrix concepts. So two-dimensional array, I think everyone knows the arrays concept. Array is nothing but a collection of similar data items. Okay, now two-dimensional array which has contained the rows, it is a combination of rows and columns. Okay, rows is represented with the loop variable I, columns are represented with the loop variable j. Right, now we will see the concept and the example, syntax, examples. Yeah, now pointers with two-dimensional arrays. Now, how can we declare the pointers with two-dimensional arrays? See, first we take the data type. Always we have to take the integer data type. Now, data type, first you write the syntax data type variable of size 1 and size 2. Size 1 and size 2. Okay, now size 1, S1 is represent the number of rows. Size 2 is represent the columns, number of columns. So now data types, we know the primary data types, integer, float, character. Now, most of the times we take the integers only. But sometimes we have to take table constraints which is contain the character also. So now data type is the integer. Observe here integer. The variable name is the m. M is means matrix. M of 3 and 3. It is nothing but a number of rows are 3, number of columns are 3. So it is represented the 3 by 3 matrix. 3 rows, 3 columns. Observe here 3 rows and 3 columns. It is a 3 by 3 matrix. The order is 3 by 3 matrix. Okay, now one more declaration is, that is example is int a of a is the matrix 4 2. Number of rows are 4, number of columns are 2. So first we specify the rows. When you are read the matrix, we outer loop is represented with the rows, outer loop, inner loop is represent the columns. The second subscripted specifies, that is nothing but a second subscripted variable which is specify the number of columns, right? The arrangement of the array elements into rows and columns only conceptually true, but it is actually in memory management. There is no specific rows, there is no columns, all are reside in memory sequentially. So just to manually we will discuss like this is row, this is column. But conceptually, that is the values are reside sequentially only. That is represented with the matrix like the now. This is the memory management. Okay, arranged. All elements are arranged linearly in memory. So in our array definition, array is a collection of similar data items. These all data items are reside in our memory sequentially. Why? Because when you are declare int a of 3, so 3 into 3, 9. 9 into size of the data type is it 2. So 9 into 2, 18 bytes of memory is allotted. Now size of the integer is 4 bytes. 9 into 4, 36 bytes of memory is allotted in sequentially. These 36 bytes are allotted sequentially only. You remember this point. Now, the first value, this is the addresses, these are the values, these are the indexes. Observe here. Now, A of 0, 0. What do you mean by A of 0, 0? 0th row, 0th column. 0th row, first column. First row, first 0th column. 1, 1. Now, because in previous declaration, you declared as A of 4, 2. A of 4, 2. So, number of rows are 4, number of columns are 2. Like 3, 6, 9, 66, 55, 43, 78, 33. Now, this is the matrix. 4 into 2. You observe here. Now, what about the 3, 3? Now, 3, 3 is residing. 3, 3 is residing, for example, 4002. That address. What is the index? Now, indexes are like you take like this. This is 0, 1. This is 0, 1, 2, 3. Now, 0, 0th element. What is the 0, 0th element? 3. 0, 1 element. Now, first row, second column, the element is 6. Now, second row, first column, 1, 0 is represent the second row, first column, 1, 0, 9, and 1, 1, that is 66, 2, 0, 55, 2, 1, 43, 3, 0, 3, 1. This is the memory management as well as the matrix notation. Okay. Now, how can we read the matrix? So another declaration. Next, we will read how to read matrix, how to print matrix. I will explain briefly. See, now two-dimensional array declaration already we know, and one more initialization is the A of data type. Subscripted variable is A. This is called the subscripted variable. For empty bracket, you observe here, empty bracket, it means now you specify the number of rows. We don't know the number of columns. So don't worry about the columns. Just you specify rows. Automatically the compiler will take the columns. So now 4, now how many elements are there? 8 elements. Now these 8 elements can be divided 4 rows. Observe here. 8 element divided the 4 rows because you specify 4 rows. So 8 by 4. 8 by 4, 2. That is the number of columns are 2 columns. That's it. Number of columns are 2. So automatically it will take the 2 columns. This is the initialization of the matrix. Right? Clear? And we move to the how to read and how to print. So now in one dimensional array A of 2, this is the scale factor. Already we discussed in our previous video scale factor. Now scale factor A of 2. can be expressed in a pointer notation star of a plus 2. So now before this, I want to explain the small example here. How can we read one-dimensional array? How can we read one-dimensional array? So first we take the int, we will discuss later, int a of 5 is this is the array, and we declare one pointer p. Now p equal to ampersand a of 0 or p equal to a, that is also acceptable. P equal to a means the base address is assigned to the pointer, but it means now pointer is a variable which stores the address of the another variable. What is the another variable? The array is the another variable. Now a of 0 index is, for example, 4000. That 4000 is assigned to p, assigned to pointer. Now we have to read the value, we have to extract the print the value, right? Read as well as write the values by using only pointer. Now coming to the reading array elements using with for I equal to 0, I less than 5, direct I want to take I plus plus, scanf percentage d, comma, p plus I. Observe here, students. Now p plus I, what is p? P is the base address. Now I value equal to 0. 0 is indicate the 0 into size of the data type. So here the size of the data type is the integer. So size of the integer is maybe 4 bytes. So 4000 into I value equal to 0. 0 into 4. 0 into 4, 0. First value is reside in 4000 address. First value is reside in 4000 address. Now I value is updated. I equal to I plus 1. I value equal to now 1. 1 less than 5. Now this condition is also satisfied. Then again the statement is executed. P plus, what is the P value? P is always 4000. P is 4000. Now I value equal to 1. 1 into 4, 4. 4000 plus 4, 4004. The second element is reside in the 4004. Third element 4008. Fourth element 4012. Fifth element 4016. That is the reading of the array elements. Now how can we print the array elements on your screen? So now I want to use the for I equal to 0, I less than 5, I plus plus. Now printf percentage 3D for 3 spaces between one element to another element. Now p plus I, first observe here. What is p plus I? P is the base address. I value is the 0 to n minus 1. So 0 to 4. P value base address plus I value 0, 0 into 4. So base address is 4000 plus 0 into 4, 0. 4000. How can we extract value from the 4000? By using the star dereferencing where operator, that is called the star. Now star of p plus I. Star means value. You are extracting value from the address. So this is the reading of printing of the two array elements, single dimensional array elements. Now we will discussing the two-dimensional array elements. So coming to two-dimensional. Now how many loop variables are required? See, in single dimension, we take only one loop variable. Now, two-dimensional array, how many loop variables are required? We require minimum, we require two variables. So, one is I value, another one is this is for the rows. And now you declared, how can you declare the way two-dimensional array A of 5, 5? It means number of rows are 5, number of columns are 5. This is nothing but a 5 by 5 matrix. So rows is represented with I, columns are represented with J. Right? So now in two-dimensional array, the values can be expressed. So this is, you observe here, this is the A of 2, 1, A of 2, 1. Now A of 2, that is value is A plus 2. A plus 2 is base address plus 2 into size of the integer, star of. So 4000 plus 2 into 4, 8. 4008. Now it's the 4008. Star of 4008, we get the value from the 4008. So now 2 1 is represented, observe here, 2 1 is represented, expressed as, now a plus 2, you observe here, a plus 2 plus 1. Why a plus 2 plus 1? Now this is the 1, that is the columns. Rows represented 2, a plus 2, 1, right? Star means that is the extracting value from the address. Okay, both refers the same element present in the first column of the second row. So in three-dimensional array, we go for the sum a plus 2 plus 1 plus 1. You observe simple, we remember base address plus I into column size, right? I into column size plus j. Simple. Base address plus I into column size plus j. Internally, I is multiplied with the size of the data type. J is also multiplied with the size of the data type. Now 4000, observe here, base address is 4000. I value is 0 into column size. Now number of columns are 3, right? Plus j value equal to, what is j value? J value equal to 0, that is into size of the data type is 4. Now here also size of the data type is 4. 0 into 4, 0 into 3. Now total 0 plus 0, 4000. First element is reside in the 4000 address. Now I want to give one example also with how the scale factor is impact without j, with j. Now, now we have a small program. Now I want to explain with the program. Better you take the new C++. This is a simple program. You directly go to the Dev C++ top share. Now sharing in two-dimensional array. You write the program. Write a C program to read and print 2D array using pointers. That's it. Now hash include stdio.h. Right? Mean is of the into a of 3, 3. Now, loop variables I comma j. Loop variables I comma j. And next, what about the other variables? Size of the matrix, like m comma n. Just to, I want to explain how to read, how to print. Next, you go for the trace, you go for the transpose, and you have different programs are there. And next, we are multiplying the matrices, right? I will take another class for all these programs. Just in two-dimensional array, how to represent two-dimensional array, how to read the two-dimensional array using with pointers, how to print and trace and transpose. That's for today class. Now a of 3 3, I comma j comma m comma n, and if any other variables are required, next we will declare. Now printf enter size of matrix, size of matrix. Now scanf percentage d comma ampersand m comma ampersand n, and take one more percentage d, because here the size is number of rows and number of columns. Right, good. Now we take the pointer variable, that is very important here, star p. That's enough. Ptr, better you take the star ptr. Now Ptr equal to ampersand A of 0, 0, 0, 0. Okay, now it's compulsory, not ampersand A. So ampersand A of rows not mentioned, there is no problem. You must mention the number of columns. Ptr equal to ampersand A of 0, 0, right? The first base address is assigned to the pointer. Clear. Now for I equal to now printf matrix elements. For I equal to 0, I less than m, I plus plus. For j equal to 0, j less than n, j plus plus. Scanf percentage d, comma. Now observe here students, p t r plus I into n for the column, I into n plus j, I into n plus j. Better you write like this. This is yes. Now reading is over. And next printf the matrix is take same for I equal to 0, I less than m, I plus plus, open bracket, take printf, already you know, printf for backslash n. This is for the next line. Now for j equal to 0, j less than n, j plus plus, printf, same thing is repeated, percentage 3d, 3d, comma, ptr plus I into column, the column is represented with n plus j. So this is the, now we should take star symbol before the expression because we extract the value from that address. Now this is a simple reading and printing. Now I want to save this program. Matrix 2D pointer. Matrix 2D pointer using the pointer. Save as C source file and no errors. Here guys, stop sharing. Go to execution. Right now, this is the enter size of the matrix 3, 3. We take the 3 by 3 because the size we are enter 3 by 3. Now elements 1, 2, okay. Elements we are enter the 1, 2, 3. Okay, now I equal to 0, I less than m, I plus plus, I increment ptr into star ptr plus I into n, I into n, and so I into n, that is for the number of columns. J equal to 0, j less than, and j plus plus. Okay, now, yeah, this is the program for the, and here you should print the elements. Now I want to read the elements. Now the 2 by 2 matrix, 1, little bit error we have. It is there. 3 by 3. Okay, sorry. This is the error. Again, execute the program. Stop sharing. Is it visible? 2 by 2. 1, 2, 3, 4. Now 1, 2, 3, 4. Now come to the program. Sharing. See, this is the program. You are execute this program. Compile and run. It is visible. No errors. Stop sharing. We go for the sharing. Yeah. Now, size of the matrix. We are enter 3, 2. Number of rows are 3. Number of columns are 2. Now, matrix elements 1, 2, 3, 4, 5, 6. Right? Now, number of rows are 3. Number of columns are 2. 1, 2, 3, 4, 5, 6. This is the matrix printed. Is it clear, guys? Right. Now I want to stop the sharing and go to the program. Go to the program. The same program we have to print the trace of the given matrix using with the trace of the given matrix. Just I want to copy the code. Just change trace matrix is here. No need of these 2 lines. Now they no need of condition also. Directly we have to print the elements. Now what is the trace equal to trace plus print the trace. So semicolon. Stop sharing. One second. Yeah, now how to write the programs, matrix programs, that is two-dimensional array programs using with pointers, right? Now in uh, already we completed one program like that is called the trace of the given matrix. Now I want to write the program for addition of two matrix using with the pointers, right? Adding string pointers. This is the important program. Now, hash include stdio dot main method. Always execution starts from the main method. You declare the pointer, uh, normal variable. First, we need three arrays. Yes, A, B, C. It is nothing but addition of two numbers. Simple addition of two numbers. Just we have to use the looping statements before reading. Now star ptr, comma, loop variables I, comma j, and size of the matrix M comma N for first matrix, P comma Q for the second matrix. Right, and is there any other variables required? Next we will take. We read the size of the first matrix. Printf enter size of matrix 1. Scanf percentage D, again one more percentage D, comma, ampersand M, comma, ampersand. Yeah, now we declare sizes as well as we read the size of the matrix. Right. Now I want to use the PTR equal to PTR. Better you take the not PTR, P1, P2, P1. Here we take declare the variables like P1, comma, star, P2, comma, star, P3. 3 pointer variables. P1 equal to ampersand A of 0, 0. A of 0, 0. In two-dimensional array, we should take A of square brackets, that is column is must. Either you take row or not. That is not a problem, but you should take the column indicated with 0. And P2 is also ampersand B of 0, 0. Done. And P3 equal to ampersand C of 0 and 0. Done. P1, P2, P3. Clear? Now we have to read the first matrix element. Printf enter matrix 1 elements. For I equal to 0, I less than M, I plus plus. For j equal to 0, j less than n, j plus plus. Okay, now here scanf. You observe here, students, percentage d for integer, comma. Here I want to use the p plus I into n. Already in last program we discussed p is the base address, I is the row, right? N is the columns, right? Number of columns, row into number of columns plus columns plus columns plus columns. This is for the P1 for the first matrix, right? Now same way I want to copy, simple, just we change the variable name matrix 2, matrix 2 elements. Now the matrix sizes are P and Q. Okay, better you read the, now this is the P2, now this is Q. Okay, actually we did not read E and Q. Done. Now the second matrix also read. Now coming to program is the addition of two matrices. Now you write the addition of two matrix. Right. For printf for I equal to 0, I less than m I plus plus. For a equal to 0, a less than q a plus plus. Now, coming to third matrix is the P3. Okay, now how can we add the elements of now P1 elements and P2 elements? P1 row, first column, P2 first row, first column. So 0, 0 element. So how to take the star of P plus I into Q plus Q equal to now. Now this is the P3. P3 equal to now star of P1 plus I into Q. Where is the Q? I into Q plus J plus now take the one bracket for both. So again R P2 plus I into Q plus that. Okay, now I into Q means I value is low. I is represented with the row, Q is represented with the column. Okay, this is the matrix addition, and I want to print the printf matrix addition is simple. I want to take this statement. I want to change the statement. No need of all this one. Before this, we take the printf packets 3D, comma, close the braces. Here I want to take the printf \n. This is the output matrix. Close bracket, close bracket. Okay, one more bracket. Sorry, not necessary, already there. Okay, now we print only third matrix. If you are interested to print matrix 1 and matrix 2, then we take the same thing is repeated. I want to take the statements here. Copy. It is the first matrix. Okay. After reading of two matrix 1, matrix 2, remove this. This matrix 2, P2. One, one, yeah, very good. This table, yeah. Now this is the program for addition of two matrices. Now you compile this program. First to save the program. Matrix addition using with pointers. Save as one error we have. What is the error we have? B3 plus I into Q plus J. Think there is no semicolon and a semicolon is there. Then we compile. L value required as a left operand of null error here. Don't worry, I will show the show the first you replace this program. Again compile. Left operand assignment. What is left operand assignment? Left operand assignment. Okay, it is correct, but small error. No, don't worry. I will show the output. Wait 1 second. Yeah, just we have to change the now. You observe here the program P3 is the output matrix. Just we take the brackets, not individually, only one bracket. Okay, P3 plus I into Q plus J. This is nothing but C of Ij in normal program. Here P3 is the first base address of P3. I value equal to 0. Sorry, 0 into Q value is now, for example, size is 3 plus J value is also 0. So first one is the 0, 0th element is reside in the base address. Next I value is updated. J value is updated and we take the 4, right, and 8 and 12. After three iterations, now J is failed, I value is updated, I is incremented by 1. Now we will execute this program. You observe here, compile and run, stop share, go to, yeah. Now I think it is visible. Now first matrix 1. Now the element is, now we are entered the 2 by 2 matrix. Second matrix also 2 by 2. Now matrix 1 elements 1, 2, 3, 4. Matrix 2 elements 5, 7, 9, 8. We assume. Now matrix 1 elements and matrix 2 elements. Wait few minutes. The matrix 2 elements. See 6, 7, 12, 10. 1, 2, 3, 4. Next line, go to next line. 5, 6, 9, 10. Okay. 1, 2, 3, 4. 1, 1. 1 is the 0, 0th element. 6 is also 0, 0th element. 1 plus 6, right? 7. Sorry. 1 plus 5 equal to 6. 2 plus 6, 2 plus, right? 2 plus 6 and 3 plus 9, right? And next one is the 4 plus 10. Okay, here we have a small, okay, this is the simple output. Okay, now stop sharing. Go to share program, close this one, close this one. You print the output matrix. Where is the output matrix? N. Here also you should take N. Now the matrix one after we need the new line. Now this is for the matrix addition of two matrices using with the pointers. Okay, only you remember one thing here. When we will read the number, P1 plus I into N plus P1 plus I into N plus J means P1 is the base address. Right. If you are extract value, so when we are adding number, then need the number. Number means that is the element from that address. So we should take the star symbol. Star symbol. So this is the addition of two matrices. Now how can we subtraction of two matrices? So just we take the, where is the code? Just we take the, instead of plus, we should take minus. We should take minus, then we can find easily matrix subtraction, right? Okay, addition and subtraction. Just we change the only operator. If you change the operator, then you will get the subtraction. And now coming to transpose of given matrix, upper triangle, lower triangle. Already we covered all these programs in our previous videos, like direct matrix programs. Already I gave one video only on matrix programs like transpose, trace, upper triangle, matrix multiplication. And next video matrix multiplication is also I will give. So this is the matrix pointers, one dimensional and two dimensional implementation, right? Okay, now thank you all. Thank you one and all. If possible, share these videos to your friends and first subscribe these videos. Thank you all. Thank you.